Number 36 says draw an energy diagram for the following reaction in which the delta H is plus 13 kilocalories per mole, the EA is 21 kilocalories, and the reaction is A plus B goes to C. Label the axes, the reactants, the products, the transition state, the EA, the delta H are the products or reactants higher in energy. So it wants us to make an energy diagram kind of like this one right here. That's what they look like. You know, energy diagrams have energy and then reaction coordinate. Okay. And so this is going to be for 36. So the axes are going to be pretty simple. Okay, the y-axis, the vertical axis, will be the energy, and the x-axis will be the reaction coordinates. I like to call that the reaction progress. So as the reaction is progressing, how does the energy of the substances change as you go from reactants and they convert into products? How does the energy change as the reaction progresses? So those are the axes. And since we're given actual amounts here, quantities of energy, I figured I would even divide the y-axis into increments. I would put a scale on the y-axis. So the reaction is A plus B goes to C. So that at the beginning of the reaction, you start with the reactants. So there you go. These are the reactants, and they have a certain energy. I'm just going to call that the zero, okay, energy. And as at the very end of the reaction progress, you're going to end up with the products. Now, the reason I put the products up here and the reactants down there is because we're told that the delta H is positive 13 kilocalories per mole, which means the products are 13 kilocalories higher than the reactants per mole. Okay, so when the delta H is positive, energy is absorbed overall during the course of the reaction. If you start with this much energy, then energy has to be absorbed overall to get to the products. So the products are going to be 13 kilocalories higher than the reactants, and this is where the scale helps out. And so the products, if you go back, that this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and that's where the products are. And so you see delta H, that's the delta H right there, the difference in energy between reactants and the products right there. Now, what the activation energy is 21 kilocalories. That's going to be the energy that it costs to get over the hill before you get to the products. So there's a barrier, okay? There's a barrier, and the difference in energy between the reactants and the very top of that barrier, what's called the transition state structure, okay? That is the activation barrier, the activation energy, and it tells us that this is 21 kilocalories per mole. So that the height of this hill should be 21. And you see how this scale is helping us out. So this is 0. We got to go all the way up to 21, and that's where we would make the top of the hill. So really, to make this graph, I just put 3 points, and then I just drew a smooth curve. All right. And we're asked to label the axes, reactants, products, transition state, E, A, and delta H. So all right, we already labeled the axes, energy, reaction, progress. The reactants are over here. Okay, what you start with, the products are over there. The transition state, that's the top of the hill. The EA, that's the difference in energy between reactants and the top of the hill. And the delta H, that's the difference in energy between the reactants and the products. And we're asked, are the products or reactants higher in energy? Well, you can see obviously that the products are higher in energy than the reactants are. So a lot in this question, but pretty interesting.